So students, let's talk about convex mirror now. And let's first do or check the rules for image formation. Thumb rules for image formation. So primarily there are three rules which we will follow. First, if the ray is coming parallel to the principal axis, if the ray is coming parallel to the principal axis, so what will happen? It will have a tendency to go pass from focus, but actually, it will go this way because it's a convex lens. Okay, that is number one. Number two is if the ray is coming, if the ray is coming to the focus, basically what will happen is it will go parallel to the principal axis. Correct. Third, if the ray passes through, comes from center of curvature, ray comes towards center of curvature, then it will be something like this. Right. So these are the three basic rules for image formation in convex mirror, and we will use these for any sort of image formation in convex mirror. Now the image in the case of this convex mirror is something like this. See, as I said, object at any position except infinity. Let's say body is here, object is here. Now here, one ray is going this side, correct? And then it has a tendency to, go towards F, correct? Right, so basically it is this, okay. Now the second ray, that is the first ray, the second ray will move towards C, so it will go, let's say, it will go this, so it will go this way, and then it will come the same way out, so this way. So these will never meet. These will never meet. Diverging rays. Diverging rays. Okay, but if I produce it backwards, then they will tend to meet somewhere here. Okay, now image in this case is formed always behind the mirror. One, formed always behind the mirror. Okay, second, it will be virtual and erect, as you can see here, and erect or upright, third, as you see, it is small, so it is diminished, and fourth, magnification is positive, because this side above the principal axis is always positive, so it is positive. However, mod of this magnification is less than 1, Now, one important thing to note here is that as object moves far from mirror, image moves towards F, so it becomes smaller. So as object moves far from mirror, image moves towards F, towards this is F. Where is F? Yeah, this is F. So it becomes smaller. Okay. So now in the second case, I will elaborate in the other slide, but I'm explaining it to you. See, as the image, this I have written, as objects move far from mirror, image moves towards F and becomes smaller. So that means as the object moves or goes to the infinity, it moves to focus, simple. Right? Right? So we will elaborate in the next slide, but just for the understanding sake, in the diagram here, I just try to explain. Now, as I said, in this case 2, object at infinity. Now, in this case, this is the lens. It's not the lens, by the way, it's mirror. So remember that. Now, in the case object at infinity, the rays will come something like this, right? This is F, this is C. They have a tendency to meet at F, right? So it will be something like this and it will be deflected away. Similarly, this will also have a tendency to meet here and it will get deflected here, right? So now one more thing, as I told you in the earlier case, right, what was image was something like this, right? First see, object was somewhere here and image was formed right here, and then it was, as it was going further, as, let me write it, as object goes further or farther, the image gets smaller towards F. Okay, so what basically it will be like this, and all that stuff. So if I have to write all the things, it will be formed at F, virtual and erect upright, to virtual and erect or upright. Third, highly diminished. Fourth, m is equal to positive in this case, and mod of m is very less than 1. Okay, so there are only two cases in the case of convex. Okay, so now let's quickly summarize it. So these are the summary notes. I will start with the easier one, which we done the most recent one, which is convex. So we know upright, erect, diminished. M is equal to positive and mod of M is less than 1. Okay, very good. Now coming on to concave mirror, 1 inverted, diminished, diminished, M is equal to negative and mod of M is less than 1. 2 inverted, magnified, last case. Okay, M is equal to negative and mod of M is greater than 1. Okay, third, inverted, same size, M is equal to negative and mod of M is equal to 1 at C. And fourth final case is upright, erect, last one, magnified, M is equal to M, negative, and mod of M greater than 1. Okay, so these are the things which you need to remember, and so this gives you the summary. Oh, I'm sorry, this is magnification, or this is it's magnified, so it is positive, right? So this summarizes the entire thing. We will be using this in the numericals, forthcoming numericals. So I'm just taking a break. Thank you.